pencil show up well enough on here?
I think so.
Okay. This is Chapter 3, Section 7, and it's the density concept. Density is a measure of the amount of mass in a unit volume of a substance, and the formula that we'll be using for density is density represented by capital D is equal to mass represented by capital M divided by the volume represented by capital V. So we can summarize this formula down to this formula. And then in the problem that we'll be solving as this first example, if 25 milliliters of carbon tetrachloride has a mass of 39.75 grams, what is the density of the liquid? So in the problem, it is a word problem, so you have to pick out the different components that will fit into this formula. So first of all, what are we solving for? What is the density? So we'll be solving for D. So that would represent, this will be our unknown in the problem. So now we have to look for the other two values. 25 milliliters. Milliliter is a volume. So this will be our V. And a mass of 39.75 grams. So this is our mass. So we just take these values and insert them into the formula. So for density, it's going to be equal to the mass, 39.75 grams, divided by the volume, which is 25 milliliters. And we put those values into our calculator, and we should come up with the answer 1.59. And our units don't cancel here because they're not the same. So we'll be left with grams over milliliters, and you can simplify that by just using a slash. So most often you're used to seeing it this way, 1.59 grams per milliliter. So that's our density. On the next example, applying density as a unit factor, this time we're going to have to rearrange that density formula to solve for a different unknown. So in this one, it's asking what is the volume. So we'll be solving for the volume, and they give you a mass of air and the density of the air as 1.29 grams per milliliter. So we've already mentioned, or it mentions in the book, that we want our density represented in units of grams per milliliter. So we'll have to convert these kilograms to grams. So we'll do that first, 1 kilogram. And if we multiply that by our unit factor, there are 1,000 grams in 1 kilogram. So our units of kilograms cancel out, and we're left with 1,000 grams of air. Now we'll look at our formula for density. We had D equals M divided by V. In this one, we're solving for volume. So we want to have the V on one side of the equal sign, and the other unknowns, or the other variables, will be on the other side of the equal sign. So if we multiply both sides by V, the V's cancel, and you'll have V up over on this side. This is algebra, and it's just showing you how to rearrange the formula. So now we have V times D is equal to M. If we divide both sides by D, we remove it from this side and put it over on this side. So our new formula is going to be V equals mass divided by the density. So now we've got our formula rearranged, so now we can insert our values from the problem. So we changed our mass to 1,000 grams, so the volume is going to be equal to 1,000 grams divided by the density, which is 1.29 grams per liter. So now that will give us, when we insert these numbers into our calculator, that will come out to be 775.19 grams. Well, the grams cancel, I'm sorry. This will be liters. So we can leave it in liters because that's what they started out with in the problem, and they didn't really specify what particular units they wanted, so we would leave it here as liters and remember to carry it out to the hundredths place. Now the next problem is going to be using density as a unit factor, and the example is a cube of silver is 5 centimeters on a side and has a mass of 1,312.5 grams. What is the density of the silver? So now we'll use our formula D equals M divided by V, and we don't have to do any rearranging here because we're looking for density. Now we have to insert our units. The mass is 1,312.5 grams. Now our volume, centimeters is not a volume. Centimeters is a measure of length. But we have a cube here, and remember we can find the volume of one of these regular objects by multiplying the length times width times height. So 5.00 centimeters the length times 5.00 centimeters the width times 5.00 centimeters the height will give us centimeters cubed, and that will be a volume. So 5 times 5 is 25 times 5 is 125. That's our volume. So we'll put that into our formula as centimeters cubed, and when we divide that out, put that into our calculator, and you should come out with 10.5 grams per centimeter cubed, and that's your density. The specific gravity